Welcome, my lovely people, to part 3 of Mathematics Paper 1 for the year 2024. So we did part 1, 2, and 3. So this is just the completion of our Maths Paper 1. So as we can see, we are starting from question 21. So this question is coming from the topic of linear programming. So we are told to write the 4 inequalities that define the unshaded region R on the diagram below. So we can start with any inequality of our choice. So I'm going first to start with the one that is cutting the x-axis only. So this will be my inequality number 1. Then this one will be my inequality number 2, my third one, then my fourth one. Right, so let's begin with the first one. So the first one is this one. As we can see, number 1, it is in dotted, then it is cutting the x-axis. So at what number is this line cutting the x-axis? So this number is 6. So you write inequality number 1, then x-axis, you just write x, cutting at 6. Then after this is done, we are supposed to identify the wanted region. So the wanted region is the unshaded. So if the unshaded is wanted, then the shaded is unwanted. So let's look at which one is greater and less. So whenever you have a vertical line, any area to the left is considered to be less, then this one is considered to be greater. So as we can see, the unshaded is less and the line is in dotted, so we're just going to put less than. So you don't have to put the equal to whenever the line is in dotted. We move on to inequality number 2. Now for inequality number 2, the line is slanting, so we are supposed to find the coordinates. So this is 0, 0. Then this point here is 6, 6. So if x1 is equal to y1 and x2 is equal to y2, then the equation will be y is equal to x. But we just have to replace the equal sign with the inequality sign. What do we mean? Let me show you by calculation. So I'm going to consider this one as x1, x2, y1, y2. So step number 1, find the gradient. So the gradient is given by rise in the y-axis divided by x2 minus x1. So we can just do the substitution. So y2 is 6, we can see, minus y1 is 0 over x2 is 6 minus 0. So our gradient is giving us a 1. Then after that is done, we can say y minus y1. So you bring now the equation of the straight line. Gradient, open brackets, x minus x1. So we can use any pair of our choice. The answer will always be the same. So let's use 0, 0. So if 0, 0 is our pair, then y1 will be 0, gradient is 1, x1 will also be 0. So we can ignore the 0 values. So 1 times x is just x, 1 times 0 is 0. So as you can see, we are getting the same value. That is the equation. Or if we want, we can find the same answer by using 6, 6. So let's try. So y minus y1 is equal to gradient, open brackets, x minus x1. So our y1 will be 6, gradient is still 1, x minus x1 is 6. So I'm going to expand the right side. So 1 will be multiplied by x, giving us x. 1 times negative 6 will give us negative 6. So I'm going to collect the like term. So I'm going to shift negative 6 to the right side. So we know that the sign will change from negative to positive 6. So 6 minus 6 is 0. So we can see that we are still getting the same value. Now, upon reaching here, all we need to do is now replace the equal sign with an inequality. So to do that, we need to identify the shaded and the unshaded. So the unshaded below here is less. So any below region is less, then the above is greater. So our area of interest is the one that is less. Therefore, our final answer will be y is less than x. So this is our second inequality. We move on to inequality number 3. So inequality number 3, the first point is cutting the y-axis at 3. Now to get the coordinates, whenever you are getting coordinates in the y-axis, the x value is always 0. So this will be 0, 3. So take note of that. Then the other point is here. So at this point, since it is in the x-axis, this will be the number 6, 0. So in the x-axis, it's number, 0. In the y-axis, it's 0, number. So we have our x1, y1, x2, y2. So let us find the gradient. So same formula. So what is our y2? Y2 is 0. X2 is, y2 is 0. Then y1 is 3. X2 is this number 6 here minus a 0. So we have 0 minus 3 is negative 3 over 6 minus 0 is giving us a 6. So to simplify this, 3 into 3 is 1. 3 into 6 is just 2. So the gradient is negative half. So the equation of the straight line will be y minus y1 is equal to gradient, open brackets, x minus x1. Now for this one, I would advise you use the first pair, 0, 3. So I'll explain why 0, 3 is preferred to 6, 0. Because for this one, the value of x is 0. So when we multiply this 0 by gradient, it will give us a 0. So no need of dealing with a fraction. So let me show you what I mean by that. So I'm going to say y minus my y1 is 3. Gradient, remember, is negative half. Multiply by x, then our x1 is 0. So we can now expand. We have negative half times x will give us negative half x. So now you see the reason why I chose this pair, so that negative half times 0 will just give us a 0. Therefore, the only task here is to move our negative 3 to the right side. So we have y is equal to neg half x plus 3. So the final answer will be, for this line, the above is greater, and we can see that we went to the greater, then the less is not wanted. So we are going to use greater than or equal to, because the line, as we can see, this line is a solid one. So this is our final answer. Then our fourth inequality is this line that is cutting the y-axis at 1. So you say y, then you write 1. The above is greater. So any horizontal line, the above is greater, then here is less. So we need the greater one. Therefore, you use greater than or equal to. So as you can see, this question is just okay. It's a matter of you practicing a lot. So let's move on to question number 22. So question number 22, question A is coming from the topic of quadratic equations, quadratic functions. So we have the diagram below shows a sketch of the graph of y is equal to x squared plus 3x plus 2 passing through the points A and B. So let's have a look at the first question. So the first question is they want the coordinates of A and B. So let's begin first by writing our equation. So in standard form, we begin with the squared plus 3x plus 2 is equal to, so I'm going to begin with this one here. So the value of A. So the value of A, of the coordinates of A, is just the x-intercepts. So what do you do when you're dealing with the x-intercepts? So to solve for x-intercepts, where there is y here, you need to substitute with 0, because we know that the value of y in the x-axis is 0. So now we have a quadratic equation. So how can you solve the quadratic equation? You can use the quadratic formula. You can use even factorization. So it depends on the method that you are comfortable with. So what I'm going to do is I'm going to use the quadratic formula and factorization. So let's begin. So remember, the coefficient of x squared is 1 and it's called the A, the value of A. Then the coefficient of x is just 3 and that's the value of B. Then the constant is just 2. Then the formula is x is equal to minus b plus or minus square root of b squared minus 4ac. Then from there, we are going to just plug in the numbers. So x is equal to, what's our b? 3. So even here, we have 3 squared minus 4. What is our A? A is 1. C is 2. Then divided by 2 times 1. So negative times 3 is negative 3 plus. Then we need to square 3. So 3 squared is 9 minus 4 times 1 is just 4 times 2 will give us 8. Divided by 2 times 1 is 2. So 9 minus 8 is 1 over 2. So to simplify this, we need to find the square root of 1. So we know that the square root of 1 is just 1 over 2. Now at this point, we need to split the equation into 2 equations. So you say x, so the first value will have plus, so we say minus 3 plus 1 over 2. The other one will be x is equal to minus 3 minus 1 over 2. Then at this point, we are going to have negative 3 plus 1. We know that we have to subtract, so we have negative 2 over 2. So the first value is negative 1. Then this will be negative 4. Same signs we add. So this will give us negative 2. So the two x-intercepts are negative 1 and negative 2. And it's making sense, as we can see, because the graph is cutting the x-axis, on the negative values. Now from there, we can see that this will be negative 1, this will be negative 2. Therefore, A will have negative 2, 0. So we are done with the values of A. Now let's move on to the values of B. So the values of B is just the y-intercept. So what are we supposed to do when you are dealing with y-intercepts? So to find y-intercepts, you substitute where there is x with 0, because the value of x in the y-axis is 0. So you say y is equal to 0 plus 3 times 0 plus 2, which is just 2. Therefore, the coordinates in the y-axis will be 0, 2. Therefore, so the easiest way is just that whenever you want the coordinates of the y-intercepts, just say 0, the constant number. So the constant number is 2, so it's 0, 2, as simple as that. Right, so let's use now factorization method. So I'm going to write my equation here. So I'm going to say x squared plus 3x plus 2 is equal to 0. So the value of a is 1, the value of b is 3, the value of c is 2. So let's find the product. So product, remember, is the value of a multiplied by the value of c. So 1 times 2 is 2. Then sum is just the value of b, which is 3. Then we need to find the factors. Now, whenever you are dealing with two positive numbers, if the product is positive and the sum is positive, then the factors should be positive. Remember that. Now, since we are dealing with numbers like 2 is a prime number. So 2, 3, 5, 7, 11. As long as the product is a prime number, the factors should be 1 and the number itself, which simply means that the factors will be 1 and these 2. So if it was a 3, it's 1 and 3. If it was a 5, 1 and 5. If it was a 7, 1 and 7. So that's a pattern. So we can now say x squared plus 1 times x is just x plus 2x plus c, 2 is equal to 0. So as you can see, the sum of this must add up to 3. So let's factorize the first pair. So the first pair, what is common is x, open bracket. So we have x plus x into x is 1. What is common here is 2. Then 2 into 2x is x plus 1 is equal to 0. So these two are the same. We factor out 1. Then this becomes a pair of this. Then at this point we need to equate each. So say x plus 1 is equal to 0, x plus 2 is equal to 0. So if we shift, we have x is equal to -1. If we do the same, x is equal to -2. So as we can see, we are getting the same values. So the choice is yours. Then we move on to question Roman number 2. So for Roman number 2, we just need a minimum value. So minimum turning point. So minimum turning point, we need to find the x. So the x is -b divided by 2a. So x is equal to negative. What's the value of b? Remember, we said the value of b is 3. Then the value of a is 1. So if we do some math, negative times 3 is -3 over 2. So that is our x value. To find the y value, you need to say y is equal to 4ac minus b squared divided by 4a. So y is equal to 4 times a is 1, c is 2, minus b is 3 squared divided by 4 times 1. So 4 times 1 times 2 is 8, minus 9. So remember, this square does not affect the negative sign, so the sign will never change, over 4. So 8 minus 9 is -1 over 4. So now as turning points in form of coordinates, this will be TP, turning point, is equal to -3 over 2, -1 over 4. So as we can see, it's making sense if you look at the actual diagram. So the turning point is here. So the value of x is located on the negative part. The value of y is also on the negative part. So make sure that the answers that you found correlates with the diagram that you have. Now we have question B. So question B is to solve the equation. So to solve simply means we need to find the values or the value of x. So look at this equation. So it's 81 minus 27x is equal to 0. So this is a question that is coming from the topic of indices, and we are solving with the unknown index. So what is our first thing? So the first thing is we need to make sure that this 81 goes to this side, or if you want you can shift negative 27 to the right side. It's the same. So if I shift 81 to this side, I'm going to have negative 27x then is equal to negative 81. So we can cancel the negative sign. Then our now equation is like this: 27 raised to the power x is equal to 81. So how do you do for a question like this one? So what you are going to do is we need to make sure the bases are the same. So which number can we come up with so that if we raise it to a certain number, we are able to get 27 and 81, and that number must be the same. So that number must be able to go into 27 and 81. 2 is not, because 2 cannot go into 27. So it's 3. Let's try 3. So let's find how many times or how many 3's do we need to arrive at 27. So I'm going to say 3, 27. So 3 into 27 will give me 9. 3 into 9 will give me 3. 3 into 3 will give me 1. So you end when it gives you 1. So this is 1. So now how many 3 do we need? 1, 2, 3. So you say 3 raised to the power 3, then multiply by this x. Let's go to 81. So we have 81. We use the same, make sure that you use the same base. So 3 into 81, so I'm going to say 3 into 8 is 2, remainder 2. 3 into 21 is 7. We go here, 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1. So we end when you get 1. So how many 3's do we want? 1, 2, 3, 4. So 3 raised to the power 4 is same as 81. Then upon reaching here, so I'm going to multiply 3 and x so that we have 3 raised to the power 3 times x is 3x is equal to 3 raised to the power 4. Since the bases are the same, therefore the powers must also be the same. So we can now equate the powers. So I'm going to say 3x is equal to 4. We divide by 3. We divide by 3. What's our x? X is 4 over 3. So that's how we can solve this equation. We move on to now the last question. So the last question is under the travel graphs. The diagram below shows the speed time graph of an object. The object accelerates uniformly from point O to point P until it reaches a speed of 20 meters per second in 4 seconds, and then moves steady from P to Q for 6 seconds, and finally comes to rest. So let's have a look at the first question. So the first question is all about the acceleration in the first 4 seconds. So acceleration is final velocity minus initial velocity divided by t. So initial is where the line is starting from. So this is our initial is 0, since it's starting from the initial, the origin. P is our final, because that's where the speed is stopping to increase. So at this point, the final velocity must be gotten to this side. So we can say A is equal to final is 20 minus initial is 0 over 4. 20 minus 0 is 20 over 4. 4 into 20 is 5 meters per second squared. So that is our acceleration. Then number 2b, we need the total distance covered by an object. So we just want everything. So as we can see, we are dealing with a trapezium. So you say distance is equal to half a plus b times height. So now how do you find the value of a? So the value of a is the distance from here up to here. So this line here is the value of a. Now to find the value of a, we need to find the difference between 4 and 10. So 4 from 10 will give us a 6 plus c. The value of b will be from where this line is starting from up to where it is ending. So we just get 15. Then height is the distance from the x-axis up to this point. So it's just 20. So we know that 2 here is 1, 2 here is 10. So 15 plus 6 will give us 21 times 10. So how do you multiply numbers like this? So whenever you have a number with a 0, like 10, 100, you just add a 0 to this number. So this becomes 210 meters as our total distance. Then for question C, we want the average speed in the last 4 seconds. So how can we find this? So to find this question, I'm going to do this. This is 10. And from 10, the journey is ending at 15 seconds. So in the last 4 seconds, so the 4 seconds is somewhere here. This is where I'm going to put, this is 14. Because 10 plus 4 is 14. So we want the speed when the time was at 14. So what are we going to do? I'm going to draw a dotted line until I touch this. Then I'm going to turn 90 degrees. So we want the value, the speed at this point. So what are we going to do? Right. Since we have a straight line, the first thing to do is I'm going to find the retardation between Q and this point. Let's call this one as R. So let's find the retardation here. Or acceleration. So acceleration is equal to final minus u over t. So acceleration is equal to final. Since it came to rest, the final here is 0. The initial, remember, becomes 20. So this 20 at this point, this is our initial point now. So it becomes the initial, but at first it was a final. So we have 20 over the time from 10 to 15 is 5. So the acceleration in the last 5 seconds will be negative 20 over 5, which is the acceleration is equal to negative 4 meters per second squared. Alright, so if we have the acceleration between Q and R, let's put this here S. What of the acceleration between Q and S? What is it going to be? So remember, as long as it's a straight line, the acceleration between Q and R is the same as the acceleration between Q and S. So that's what we are going to find. So for this one, we'll say the initial is still 20, but the final, we don't have. So the final, we just put V. So we are solving for V. So you say V is equal to initial plus initial plus AT. Use this formula. final is equal to initial is 0. Sorry, not 0. Initial is 20. This value here, 20. Plus the acceleration, remember, is -4. Don't ignore the negative sign. So it's -4 time. Now, this is why you bring now 4, because we want the average speed in the last 4 seconds. So you use 4. So it will be 20 negative times positive is negative. 4 times 4 is 16. So 20 minus 16 will give us 4 meters per second. So it means that when the time, in the last 4 seconds, the speed here was 4 meters per second. So that was the concept behind this question. As we can see, it's simple. So that's it for this video. Thanks for watching.